All right, geometry, really huge, important section in chapter 12, covering what are called inscribed angles. State test loves inscribed angles, so please be aware. So yeah, let's go take a look at some of these ideas. All right, so first of all, what is an inscribed angle? An inscribed angle is an angle whose vertex is on the circle. So that's a very important idea. The vertex, let me change to blue, I like blue. The vertex is on the circle, and then the sides of the angle are chords. So in this picture here, angle ACB, or angle C, is the inscribed angle because C, the vertex, is on the circle. All right. The intercepted arc is the arc in between the sides of your angle. So arc AB is the intercepted arc. So in this picture, inscribed angle C intercepts arc AB. And again, you could also call this angle ACB. So then C, the vertex, is the vertex, and then AB would be the arc that it intercepts. And again, notice they're the endpoints of the angle, or the other 2 points naming the angle. So this inscribed angle theorem is a huge idea. It says the measure of an inscribed angle is half the measure of the arc. So in this picture, angle ABC is the inscribed angle. Again, you could call this angle ABC. B is the vertex, or just angle B. It's going to be half of its intercepted arc, and the arc it intercepts is, of course, arc AC. Right? So that is a huge idea, this 1/2 idea. Now, we can also write this from the perspective of the arc. If I wanted to find the measure of the arc AC, what I would do to this angle measure is I would multiply it by 2. 2 times, and let's just go with the measure of angle B. So keep that in mind too, that the inscribed angle is half the arc, but the intercepted arc is double, or 2 times, the inscribed angle. And I just want to do a comparison real fast. So let me try to redraw this picture. Let me try to put A and C where they're at. So again, this is still the arc we're talking about, arc AC. But now what if we look at a central angle? So say we put B as the center. Right? Well, I hope you can see that this angle measure here is not the same as this one here. They're different, right? Isn't this central angle look a bit bigger? So remember that the measure of a central angle is equal to the arc. So this angle B is equal to, so in this case, the measure of angle B equals the measure of arc AC, right? For central angles. Again, that's a central angle. And again, the reason it's a central angle is because the vertex is the center of the circle. Versus here, for the inscribed angle, it's equal to half the arc. Okay, so again, this idea right here. So keep that in mind, the difference between inscribed angles and central angles. Very important idea. Oh, sorry about that. Let me erase this. Okay, so we have 3, three important corollaries to talk about. So a corollary is just an idea that can come from some previous idea. So these are 3 corollaries based off of the inscribed angle theorem. So the first one says 2 inscribed angles that intercept the same arc are congruent. So let's take a look at this picture here. I have angle A. I'll just trace it. Angle A intercepts this blue arc. Let's call it CD. So the measure of angle A is going to equal 1/2 the measure of arc CD. And then I'll change colors. Angle B, this angle also intercepts arc CD. So of course, the measure of angle B is also going to be 1/2 the measure of arc CD. And because they are equal to the same thing, angle A and angle B have the same measure, which means they are congruent. So this would force angle A to be congruent to angle B. So there we go. Second corollary, it says that the angle inscribed in a semicircle is a right angle. So angle C, this angle ends at a diameter. So call this A, B, and let's put a random point D up here. So the arc that angle C intercepts is this semicircle. So the measure of angle C in this picture is going to be half the measure of semicircle ADB. Well, we should know that a semicircle is 180 degrees. And what is half of 180? Half of 180 is 90. The measure of angle C is going to be 90 degrees. And that's what it shows. Okay, and last but not least here, the opposite angles of a quadrilateral inscribed in a circle are supplementary. So this quadrilateral ABCD is inscribed in the circle because all four vertices touch the circle. So let's focus on angle A and C, opposite angles, A and C, right? Not consecutive angles, not A and B, A and C. So here's angle A. So angle A opens up to this arc. So the measure of angle A would be half the measure of arc BCD. And then let's look at arc or angle C. Angle C opens up to this arc. So the measure of angle C is going to be half the measure of arc. Let's call it DAB. Well, if you look at this picture, what do these two arcs make? BCD and DAB make the circle. So if you add these two together and you add these two together, you'll get the measure of angle A plus the measure of angle C equals. Well, if these two arcs equal the circle, remember that a circle equals 360 degrees. So together they equal 360, but it's half of 360. And what is half of 360? Half of 360 is 180. And there's your idea of being supplementary. Okay. So there's where these three corollaries come from. Pretty easy to prove based off of the inscribed angle theorem. So you'll use these throughout the day. And last but not least, what if we involve a tangent from section 12.1? Well, the measure of an angle formed by a tangent and a chord is still half of its intercepted arc. So in this picture here, angle C is the angle. The arc it opens up to is a minor arc BC. So the measure of angle C is going to be a half of this minor arc that it opens up to, BC. In this picture, angle C is also an angle formed by a tangent and a chord. It's going to be equal to half of the arc it opens up to, and now you have this major arc. So it's three letters BDC, right? So this actually applies to the first picture, and that applies to the second picture. But again, the whole day, if an angle's vertex is on the circle, it is 1/2 the arc. Angle equals 1/2 the arc. Please, please, please remember that if the vertex is on the circle. All right, so the next video is going to talk about some of the problems involving inscribed angles.